Hello guys, welcome back to my YouTube channel. Myself Rakshit, I'm from Sri Venkateswara College of Engineering. Today we are going to discuss about binomial probability distribution. Binomial probability distribution. The binomial probability distribution is a discrete probability distribution that models the number of successes in a fixed number of Bernoulli trials. This is the example graph I have showed in this PPT. The definition of binomial probability distribution. The binomial probability distribution is used to model situations where there are two possible outcomes, successes or failure, and each trial is independent of the others. Characteristics of a binomial distribution. There are three characteristics. First one is fixed number of trials, second one is independent trials, third one is two possible outcomes. First, we will discuss about fixed number of trials. A binomial distribution consists of a fixed number of trials, which is denoted by n. And second one is independent trials. Each trial is independent of the others, meaning that outcome of one trial does not affect the outcome of subsequent trials. And the third one is two possible outcomes. Each trial has exactly two possible outcomes, success or failure. Then, what is the formula for calculating probabilities in a binomial distribution? The probability of getting exactly x successes in n trials can be calculated using the formula P of capital X is equal to small x, which is equal to C of n comma n into p power x into 1 minus p power n minus x, where c of n comma x, which is represented as the number of combinations. And next we'll move on to formula of mean, standard deviation and variance. First we will discuss about mean. The mean of a binomial distribution is calculated as mu is equal to n into p, where mu is mean and n is the number of trials and p is probability of success, where mu is denoted as mean. And standard deviation. The standard deviation of a binomial distribution is given by sigma is equal to square root of np into 1 minus p. And finally third one is variance. The variance of a binomial distribution is equal to variance of x is equal to n into p into 1 minus p. These are the examples. Example problem for calculating probabilities. Suppose we have 10 independent trials and the probability of success is 0.3. What is the probability of getting exactly 4 successes in these 10 trials? To solve this problem, we can use the binomial formula and calculate, which is equal to p of x is equal to 4, which is considered as c of 10 comma 4, which is denoted as 10 c4 into 0.3 into power of 4 into 0.7 to the power of 6. By solving this equation, we will get the solution for this question. And the example for flipping a fair coin. Let us consider an example of flipping a fair coin 10 times. In this case, the probability of success, which means getting head, is p, which is equals to 0.5, because in a coin we have two faces, one is heads and one is tails. We are now calculating about heads, so probability of getting is 0.5 and the number of trials is the given question is 10. We can use the binomial probability distribution formula to calculate the probabilities of getting different numbers of head in 10 flips, which is denoted as, for example, we will do in 6 sets, that is p of x is greater than or equal to 6, which is equals to p of x is equals to 6 plus p of x is equals to 7 plus p of x is equals to 8 plus p of x is equals to 9 plus p of x is equals to 10, which is equals to 10c6 into 1 by 2 power 10 plus 10c7 into 1 by 2 power 10 plus 10c8 into 1 by 2 power 10 plus 10c9 into 1 by 2 power 10 plus 10c10 into 1 by 2 power 10. In this equation, 1 by 2 power 10 is common, therefore we take it as common, and the remaining is 10c6 plus 10c7 plus 10c8 plus 10c9 plus 10c10. In the calculator, we can get the value of 10c6 and 10c7 and 10c8 and 10c9 and 10c10. These are the values of the above equation, and finally we will get the answer as 193 divided by 512. As similar as this problem, previous problem is also same. And the example is flipper a coin x is equals to 0, which is equals to 10c0, 0.5 power 0, 0.5 power 10 minus 0, which is equals to 0.00098, which is equal to 0. And the next example, a fair coin is tossed 3 times in succession. If the first toss produced a head, then the probability of getting exactly 2 heads in 3 tosses, including the first toss, is probability of getting is 2, and the total n value is 4, which is equal to 2 by 4, which means 1 by 2. So answer is 1 by 2. We have 4 outcomes of getting first tossed as heads and 2 outcomes having exactly 2 heads. So 2 by 4, which is equal to 1 by 2. Properties of the binomial distribution. Squared distribution. The binomial distribution is squared for values of p that are close to 0 or 1. Next, asymptotic to normal distribution. For a large number of trials, the binomial distribution approaches a normal distribution. Expected value and variance. The expected value of a binomial distribution is equal to the mean, and the variance is equal to the mean multiplied by 1. Real world applications of the binomial distribution. Quality control. The binomial distribution is used in quality control to determine the probability of defects in a production process. Market research. Market researchers they use binomial distribution to analyze survey result and predict customer behavior. Biostatics. The binomial distribution is used in biostatics to model the probability of success in clinical trials or epidemiological studies. Finally, the conclusion is the binomial probability distribution is a powerful tool that allows us to calculate the probability of a specific number of successes in a fixed number of trials. It has a wide range of real-world applications and is essential in the fields such as quality control, market research, and biostatics. Thank you guys. Thank you for watching my video. Please do like, share, and subscribe to my YouTube channel.